Hi everyone, today we'll be looking at these hormones and their stimuli for secretion, site of secretion, and what are their actions. So these are some of the gastrointestinal hormones. First of all, gastrin. Now, gastrin is secreted especially in the presence of protein. Protein's presence triggers gastrin. Fats presence triggers cholecystokinin, and acids present triggers secretin. And then glucose present triggers GIP, which is also known as incretin. Incretin or glucose-dependent insulinotropic peptide called gastric inhibitory peptide or mortallin. And fasting triggers mortallin, right? So basically, what happens first of all, starting off with gastrin, which is released when there's excessive protein, right? So when there's a lot of protein, G cells of the antrum of stomach and then duodenum and jejunum, they're going to they're going to release gastrin. And gastrin will do what? Gastrin will cause excessive secretion of gastric acid and will cause mucosal growth. Now, gastric acid secretion happens where? Stomach. So that's the reason these cells are also present in antrum so that they can increase gastric acid secretion. So whenever there's excessive protein in the diet, gastrin is released. Whenever there's excessive protein in the diet, gastrin is released by the G cells of the antrum, duodenum, and jejunum, and it will increase the gastric acid secretion. So that will break down the proteins and it will also cause mucosal growth, right? Now, gastrin, we know what does gastrin do? Gastrin increases the gastric motility as well as intestinal motility. So someone asks you, so this is a good answer that gastrin increases gastric as well as intestinal motility, right? So yeah, these are 2 points you need to know. Then moving forward, we have cholecystokinin. I've already told you it's secreted when there's excessive fat in the diet, right? So then cholecystokinin gets secreted, and this gets secreted by the I cells. First you had G cells, that was quite easy to remember, but for cholecystokinin you have I cells, and now everything will be duodenum, jejunum, ileum, duodenum, jejunum, ileum. This will be duodenum and jejunum. Ileum is not there. Duodenum and jejunum, ileum is not there. Okay? So duodenum, jejunum, ileum, I cells are going to secrete cholecystokinin whenever they detect excessive amounts of fat. What will this cholecystokinin do? It will cause pancreatic enzyme secretion. So pancreatic enzymes are going to be secreted and they will ensure that all of that fat is broken down or dissolved. And then also it increases gallbladder secretion. Gallbladder will secrete bile and that bile will help with absorption, breakdown and then eventually absorption, right? And also another thing about cholecystokinin is that, see, it acts on the gallbladder, that's something we know. But there's one thing that I want you to remember. So, since gastrin was increasing gastric motility and intestinal motility, secretin will decrease gastric motility and intestinal motility. Cholecystokinin, on the other hand, it will decrease gastric motility, but it will increase intestinal motility. So see, somehow you need to remember that it decreases gastric motility. I'll explain this to you in a manner that you won't have to make any mnemonic because at this point you can't even remember so many mnemonics, you know. So this is going to inhibit the gastric motility. In other words, it's going to inhibit the stomach emptying. That's the reason that fast food, right? Fast food, it makes you feel very full. That's because it has a lot of fat in them, the fast food. And then because of fat, a lot of cholecystokinin is released. That cholecystokinin is going to inhibit the gastric emptying. So that's one way in which you can recall this. That fat is in fast food. And after you consume fast food, a lot of cholecystokinin is released. That cholecystokinin will do what? That cholecystokinin will increase the gastric motility. That's why whenever you eat a lot of junk food, so for a long period of time, you feel like there's so much food that's just stuck in your esophagus, in your stomach. All right. Okay. Now moving forward, we have and also it secretes bile. I hope that's clear, and it inhibits gastric emptying. So there's yeah that, and if it inhibits gastric emptying, it's going to suppress hunger. That's the reason our moms tell us not to eat junk food, otherwise we won't be able to eat the food at home. Sorry. Secreted. It's secreted whenever there is excessive acid, right? And what does this do? This is first of all, this is secreted by the S cells. So S is easy, right? Only I was difficult. But duodenum, jejunum, and ileum. And this stimulates bicarbonate secretion, and bicarbonate secretion by pancreas and by mm, you can say gallbladder. So that's biliary bicarbonate secretion. So pancreatic bicarbonate secretion and biliary bicarbonate secretion, right? And then I told you that it inhibits both the gastric and intestinal motility. So you can say that it inhibits gastric acid secretion, it inhibits gastrin release also. So obviously, if it will inhibit gastrin, it will simultaneously inhibit gastric acid secretion, right? And GIP, glucose dependent insulinotropic. This is secreted when there's excessive protein, fat, and carbs, all of them, or when there's excessive glucose, and it's secreted by the K cells of duodenum and jejunum. This is going to cause insulin to be released, and this is going to inhibit gastric acid secretion. So this also inhibits gastric acid secretion because obviously you do not need acids anymore. There's already so much acid in the body, right? And you do not need any more again gastric acid uh, because right now that carbs which are there or whatever glucose is there, it will be taken up by the insulin, right? Insulin is being secreted, so do not want gastric acid to hinder any of that. Then you have motilin. This is produced during the fasting phase, right? So this is produced during the fasting phase. Now what happens is that uh, what's the stimulus? Fat, acid, and nervous. And it's secreted by the M cells, motilin M cells of duodenum and jejunum. What does it do? It increases gastric and intestinal motility. That's why whenever you're feeling hungry, so the gastric motility increases so much, so and even the intestinal motility increases so much. That's because they're trying to wipe away or remove any of that bacteria or any of that food contents that's there. So they're trying to make use of the maximum food that was available, right? And yeah, here this is a chat GPT version, so let's just read that as well. It might be fruitful for you guys. So gastric, it's triggered when there's excessive protein, right? And then stomach distension and vagus, secreted by G cells. Gastric acid increases and stomach mucosal growth increases. Cholecystokinin, whenever there's a lot of fat and also protein, it's secreted by I cells of the duodenum and jejunum, and also ileum, if you can recall. And it increases pancreatic enzymes, it increases gallbladder contraction, and decreases gastric emptying. The thing is that whenever there's increased fat, right, in the food, it'll go into the intestinal cells are going to detect that, oh, there's so much fat. Now what they'll do, the intestinal cells are going to decrease the gastric emptying because they'll send an alarm to the stomach that wait, stop, there's so much fat, let me first digest or let me first absorb this and then I'll tell you what to do next. So it basically alarms the stomach that wait for a few minutes, let me absorb whatever fat is there first. And then yeah, so gastric emptying, that's the reason it's inhibited, right? And also I've already told you, I've given you the analogy with the fast food, so please remember that because that's one way that you'll remember that cholecystokinin is released in the presence of fat, and it causes pancreatic enzymes increase, gallbladder contraction, and it also decreases gastric emptying. Secretin. This is secreted by the S cells in the duodenum, jejunum, and ileum, right? And this trigger factor for this is acid. Whenever there's excess acid, so it's going to increase pancreatic and biliary bicarbonates, and it's going to decrease the gastric acid or gastrin. GIP, its trigger is everything: glucose, fat, protein. Glucose basically the carbs, right? And it's secreted by cases of duodenum and jejunum. It increases insulin release and it decreases gastric acid. Motilin, between meals, fasting, and it increases GI and secreted by M cells of duodenum and jejunum. It increases GI motility, initiating migrating motor complex. Migrating motor complex. What is that? Let's look at that as well. Before that, again, protein. If there's protein, gastrin will be released. Gastrin, gastric acid. If there's fat, CCK will be released. CCK will release pancreatic enzymes and bile, and yeah, and it will decrease the gastric motility. If there is acid, secretin will be released and it will release bicarbonate and pancreatic and biliary bicarbonate. If there's glucose, GIP will be released and it will increase insulin and it will decrease the gastric motility. If you're fasting, motilin will be secreted and that's going to increase the GIT motility, right? And intestinal motility. Yes, we're talking about MMC. What is that? Right. So here, MMC, where is it? Let's just look at it. It will be here. MM says basically migrating motor complex. What happens is that between meals, GI tract is not sitting ideally. It doesn't mean that it has nothing to do, so it will just stop working. There's no peristalsis at all, nothing is happening. No, it's not like that. In fact, motilin hormone is secreted that causes periodic strong contractions that is going to sweep the residual food and the bacteria. So this is known as migrating motor complex.